Hi, this is Kamya Vashne, and it's my pleasure to present the paper The Intersection of Carbon Sequestration and Habitat Provision in Built Environments Building Rating Tools Comparison, authored by myself, Dr. Maybrit Pedersen-Zari, and Dr. Nilesh Bakshi from Victoria University of Wellington. The research is interdisciplinary and it translates ecological knowledge into an architecture context in order to achieve a regenerative built environment. This paper aims to explore the potential relationships between carbon sequestration and habitat provision in building design, and how can these be implemented as an important part of building rating tools to address climate change and biodiversity loss. The expansion of built environment is a significant driver of climate change and biodiversity loss. Human actions have caused approximately 1 degree Celsius of global warming above pre-industrial levels. If this continues at the same or an accelerated pace, average global warming is likely to reach at least 1.5 degrees Celsius between 2030 to 2052. And the impacts on biodiversity, including species lost and extinction, are estimated to be increased with the rise in temperature. Moreover, urbanization often impacts biodiversity, landscape processes, the quality, quantity, and connectedness of habitats. Recognizing the importance of addressing these issues, over the past 3 decades, sustainable building practices have become more common. Starting with BREEAM in the UK, there has been a significant rise in the number of building rating tools that promote sustainable development. LEED from the USA, Green Star in Australia, New Zealand, and South Africa, Living Building Challenge, developed in USA but globally used, CASB from Japan, along with many more, has subsequently emerged as building rating tools for assessment. Buildings certified by such rating tools are considered to be potentially energy efficient with minimizing environmental impact. Although neutral or minimal environmental impacts are worthwhile targets for carbon, energy, waste, or water, there is a significant evidence of the need of net positive or regenerative targets for the building design. These can potentially be achieved by designing for the provision of ecosystem services. Ecosystem services. The benefits humans derive from ecosystem functions, either directly or indirectly, are known as ecosystem services. Millennium Ecosystem Assessment categorizes ecosystem services into provisioning, regulating, supporting, and cultural services. Pedersen-Zari translated ecosystem services thinking into the context of built environment and bundled them. Amongst all ecosystem services, this research primarily focuses on climate regulation, specifically carbon sequestration and habitat provision. The reason for selecting these two ecosystem services is that there is a potential relationship between design strategies to increase carbon sequestration and habitat provision and to address interrelated issues of climate change and biodiversity loss. This figure illustrates that both climate change and biodiversity loss may be reduced by regeneration of ecosystems. Climate regulation relates to the regulation of temperature, precipitation, and other biologically mediated climatic processes at global and local levels. Global response to climate change through built environment include mitigation strategies such as electric vehicle, adaptation strategies such as changing to building codes, remedial strategies such as use of renewable energy, but little attention is given to carbon dioxide removal. Habitat provision in the context of built environment comprised of several other ecosystem services, which are genetic information, pollination and seed dispersal, fixation of solar energy, biological control, and species maintenance. The main strategy for increasing carbon sequestration in the built environment is to increase vegetation. Similarly, ecological corridors in the form of domestic gardens, green walls, and green roofs at local and regional scales are potential solutions to conserve biodiversity within urban landscapes. This table lists some examples of how designers can commonly apply the strategy of increasing vegetation. It is important to analyze the contribution of carbon sequestration and habitat provision ecosystem services in the built environment by focusing on the synergies and trade-offs between them. Synergies provide a long-term solution to the mitigation of climate change and biodiversity loss. On the other hand, trade-offs are extremely important to identify so that increasing one ecosystem service does not inadvertently reduce another. Example of trade-off Although pinus radiata sequester carbon faster than New Zealand natives, pine forests are not as good as native ones in terms of providing habitat. Example of synergy. In case of green roofs, intensive green roofs sequester more carbon compared to extensive green roofs. Also, intensive green roofs are often better for species diversity and richness. To examine whether ecosystem services are or are not included in the existing building rating systems, a comparison is made with three building rating tools: the LEED, the Green Star, and the Living Building Challenge. For the purpose, firstly, a series of matrices were prepared in which each aspects of building rating tools were examined by selecting either of the three options: fully considered, partly considered, or not considered at all, on how they account for the generation of ecosystem services. Based on those selections, wheel diagrams were prepared. Figure represents the best case scenario. The same color tone indicates that the respective ecosystem service is fully considered and acknowledged in the building rating tools. The lighter tone of the same color indicates that it is partly considered, and the white color indicates that it's not considered at all. The wheel diagrams illustrated comparison of building rating tools made for all ecosystem services. However, for this paper, only carbon sequestration and habitat provision aspects are discussed because the scope of this research is limited to these two ecosystem services only. Starting with lead NC focuses on carbon reduction and minimization of carbon emissions. This is evidenced from various strategies provided by lead NC, such as reducing car park footprints, energy optimization, and increased use of renewable energy. After analysis of lead building rating system, it doesn't appear to have any aspect that relates specifically to carbon sequestration. Lead NC also have a subsection of protect or restore habitat under sustainable sites category and sustainable land protection under location and transportation category. These aspects tend to minimize the impact on biodiversity and ecosystem health. This indicates that climate regulation and habitat provision bundle ecosystem services are partly considered in lead NC. Green Star NC provide credits for carbon reduction and minimization of carbon emissions. This is evident from the strategies provided by Green Star, such as greenhouse emission minimization, cyclist facilities, and mass commuting transport. However, the Green Star NZ building rating system does not appear to have any aspect that relates specifically to carbon sequestration. In terms of habitat provision, Green Star NZ aims to encourage and recognize the minimization of ecological impact. This relates to minimizing the impact on biodiversity and ecosystem health. These aspects indicate that climate regulation and habitat provision bundle ecosystem services are partly considered in Green Star New Zealand. The LBC not only aims for carbon emission reduction through various strategies, but also aims for the net positive carbon. However, the net positive carbon is only limited to the use of carbon sequestering materials. Moreover, LBC has an imperative which relates to habitat provision, that's ecology of place. However, the effectiveness of habitat provision strategies for the enhancement of the ecological performance of a specific site should be clearly monitored over the time. Therefore, climate regulation and habitat provision bundled ecosystem services are partly considered in the LBC as well. Climate change and biodiversity loss are often treated as separate issues. However, they are interrelated and must be addressed together. The strategies to provide carbon sequestration through the built environment could potentially address climate change. The strategies to provide habitat provision through the built environment could potentially address biodiversity loss and could result in generation of ecosystem services. The strategies to address carbon sequestration and habitat provision in the built environment often overlap, as indicated by the shaded portion, mostly because they are both typically reliant on increasing the amount of vegetation in the built environment. Therefore, ecosystem-focused regenerative built environment development may reduce the direct and indirect impact of climate change and biodiversity loss. There is a scope to understand different strategies in detail which not only enhance biodiversity by providing habitat but also sequester carbon from the atmosphere. This research suggests that there is a need to identify how to plot synergies and trade-offs between different building technologies and to identify optimal solution through the medium of building design. Lastly, to move towards regenerative design, building rating tools need to assess buildings in a way that encourages design for the provision of ecosystem services, aiming at improving ecological health along with human health. That concludes the presentation. Thank you for your time, and I'm happy to take any questions.